All right, I've gotten some emails from students about being concerned about the content that we've gone over in the last 3 weeks, the stuff on exam two. Admittedly, like I said previously, exam two is the one that most students find the most difficult because it is the mathiest. But from my point of view, exam two is one of the easier exams because the questions I'm going to ask are very much sort of set in stone. There's less wiggle room, less ways for me to get creative. Trust me, I'll still find one way to get creative, to get those extra credit questions in there, but most of the questions have to be pretty much set in stone. So I'm going to just do a quick review for each part in terms of the questions you could expect to see on the exam and the content that we covered. I'm also going to do videos of the knowledge checks for each week and for the Kahoots for each week to sort of break down some of the issues that you might have run into in case Professor Steele didn't go over all the different questions as you did them in class. I'll also talk about some of the most common mistakes I saw on the different worksheets. So that way you kind of get an idea of hopefully some clarification of stuff that was going wrong. As a heads up, the week after spring break, which is your exam two, that's the last week I'm out. So after that, I'll be back to handle the last bit of content, which to me is actually the most difficult, the inference stuff, but it's also like what the whole point of the course is. So I'm excited to be able to come back and do that part with you guys. Okay, so part 4, probability. First off, questions and things that you need to know how to deal with, right? The biggest thing in part 4 in my mind are the different displays, the ways that we can visualize probability, right? And we already talked about the fact that our warm and fuzzy on the test, the very first question you see is going to be that tree diagram. So that's why I gave you a tree diagram worksheet. It was not supposed to be busy work. It was supposed to be an opportunity for you guys to see if you understood the tree diagram. And like I said, there's at least 3 more of those examples in the part for homework, right, or practice problems. And then there's one on every single old exam, including the one you had before. So you can see that tree diagram many, many places. If I were you, biggest thing about the tree diagram is it takes everyone, right? It splits people based on 2 different criteria, which are complements of one another. And then it splits them one more time based on which section we were in. So given A, or given a complement, given the person didn't go to the review session, or given the person was actually guilty, or whatever the heck our first split was, what is the other possibility, right? And then we could split this way. And then if we multiply down these, we get all of our ands. And it doesn't matter what order we put the ands. The only one that the order matters on is the middle probabilities, those conditionals. So yada, yada, yada. This is something you might want to put on your note card, right? The sort of framework of what the tree diagram looks like. I don't dock a ton of points for the notation being off, but I do dock some points, as some of you saw on that worksheet. What comes after the tree diagram? Very straightforward. I'm going to ask you for the other probabilities. So if we had guilty versus innocent here, this would be convicted versus acquitted. Or we had, went to the final review session, this would be past the final. So whatever the other probability is, the thing that we split up afterwards. The other thing that I'm definitely going to ask for is the opposite conditional. So given someone passed the final, what was the probability that they went to the review? Given that the luggage arrived on time, what was the probability the flight was delayed? Flipping the different, the conditional that we had originally. And just remember, I'll also put down here, there are 2 different things that are 4 different types of probabilities, right? The thing by itself, our marginal, our joint, the thing together, our or, and also our conditional. These 2, the thing by itself and the and, these are on the displays for the most part. For the tree diagram, we have to actually add up to get that probability of B, but both of these are on a contingency table. So if you're somebody who makes a contingency table, you can pull these straight off. Now these 2 are the ones that you have to use the formulas for. So there were a lot of people on the worksheet for week 6 who actually did a formula to solve for and when they had and. It was right here on their tree. So you guys did extra work you didn't need to do to get out a number you already had. The only time we have to do formulas is for our conditionals and for our ors. And this is actually where a lot of students have mistakes. The conditional is the most common place to make a mistake. Most students will just give me the and here, but they need to make sure that they divide by whatever was given. So as soon as you have this, think of it almost as like a division. We're going to divide by whatever's behind the line. So that was our tree diagram. You got a lot of places to practice that. Like I said, the other thing that's guaranteed to be on the exam 2 in terms of displays is either a contingency table or a Venn diagram. Since they display the same thing, right, I could ask you about either one. Now, remember, we know that we're dealing with a tree diagram when we have conditionals, and we know we're dealing with a contingency table or a Venn diagram when we have ands. That's how we're going to deal with, oh, it's a contingency table or Venn diagram. But again, I tend to make this easier for you on the or on the test. I actually usually will say create a Venn diagram, create a contingency table before I ask you those questions. So you should be good and ready to go here. And again, same things in terms of stuff I could ask you. The things by themselves, the ands, they can pull straight off the table. The conditionals and the ors will need a formula. So just make sure you have those sort of formulas down and you just pay close attention. It's really easy to miss out on a complement and not put it into the formula, right? And that happened to a couple of people on the worksheet. They wrote down the correct notation here, but then they forgot the complements when they went and did their formula. So those are two, and those are 2 big points. I think the tree diagram is usually like 15 points. The contingency table is another 10 or so. So, I mean, that's a quarter of your test on those 2 big displays and all the questions that come after. Now, if you're on the test and for some reason you can't finish or fill out the tree diagram or the Venn diagram, I will try to remember to tell Professor Steele, if you need to, you can go up to her and have her fill in the values for you. So that way you can at least do the questions that come after. But even if she doesn't, or if I forget to tell her that or whatever might happen, you just make up numbers here. We know that these have to add up to 100. Make up numbers and then use those numbers to answer the rest of the questions. Because if your work is consistent with whatever values you have, I'll give you partial credit. So if you're lost, make something up. Don't leave the thing blank, especially because these 2 questions are multiple parts. One, you got to make the diagram, and then you got to answer those questions. So make sure you're not losing out on those easy points afterwards. All right, so the next piece of or thing that you'll see in terms of part 4 on the test, I know this is one that people struggled with a lot, so I'll make a separate video to kind of break this down. But that's independent and disjoint events, right? And we'll see this when I go over the knowledge check. We'll see this in the Kahoot. We'll see this when I talk about discussion board 6, because this came up again and again and again, and we did struggle with these ideas. So another thing you might want to have on your formula sheet, right? I mean, on your note card, you might want to have whatever definition works for you for these 2 values, independent versus disjoint, whatever it is. Like independent is there's no relationship. Maybe you're writing down your sweet formula of like probability of A and B is equal to the probability of A times the probability of B. Maybe you're writing down that other idea that knowing B doesn't give us any new information, so this is just the probability of A. Maybe you're writing down one of the examples, whatever it is that works and resonates for you. Whereas disjoint means that there's no overlap, right? And this was an issue a lot of students had, is they would say, oh, there's no overlap, but the random phenomena weren't particularly clear. So in discussion board 6, a lot of people talked about pulling cards, right, from a deck. And they would talk about, okay, well, if A is pulling a king and B is pulling an ace, well, these 2 things are disjoint because you can't pull an ace and a king. Great. But then they went on to the next part and they said, well, if you pull a king first and then you put it back, that doesn't, or if you pull a king first, that influences whether or not the probability the next card is an ace. So what the issue was for a lot of people on discussion board 6 was not really thinking about what their random phenomenon was. Are we pulling one card? Are we pulling two cards? If we're pulling one card, yes, these two things are disjoint. It's impossible to get an ace and a king if you're pulling just one card. But if you go on to talk about like, well, the next card, now you're not pulling one card, you're pulling two cards. And it is possible to get a king and then an ace. So those would be joint. So you do have to pay very close attention to what the random phenomenon is that you're describing those events for. So I'll break down disjoint and independent a little bit more in the knowledge check and the Kahoot breakdowns. But just know I always have a question about independent or disjoint. There are two different questions I really like for independent and disjoint. One is to describe relationships like this and ask you, right? And you have your A, B, C, and D are all the different combinations. Disjoint and independent, disjoint and dependent, joint and independent, right? I have all the different possibilities. And the only thing I'll say to you here is on the test, take the time to write down what you do know. So if you know these different definitions, write that down, get some points there. If you are convinced that they are independent, write that down and write down why. Because this is a 4-point question, right? And if you have given me solid evidence that you know half of it, I will give you half of those points. If you just circle this and yeah, maybe you are aware that they're joint and you know why, but you haven't written down these are joint because it's possible, blah, 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 then, or the probability is, then I don't know that and I can't give you any partial credit. So I'm not going to be generous with partial credit unless you write something down. So write something down. And then I should have written down the probability piece here, right? If they're disjoint, their and is equal to 0. So that's one question I love to ask. The other question is the one you guys saw in the Kahoot, the last like 4 questions, right? Every possibility. If I tell you that the probability of A is equal to 0.2 and the probability of B is equal to 0.4, and then I ask you, I can ask you for and, I could ask you for or, and I could tell you they're independent or disjoint. And right there, I could go ahead and tell you right now what those 4 different answer choices are. Because the and for disjoint would be 0. The or for disjoint would be 0.6, because we just add them together and subtract 0. The and for independent, well, that is 0.08, right? Because we multiply the two of them together. And the or, oops, that's not an or. The or for independent, well, that's 0.52. The 0.6 minus the point. So this is another one where the answer choices are right there. And the most common mistake students make, if this is the question on the test, is just not reading for what I'm asking for. This reminds me a lot of that little 2x2 table that we made for the different measures of center and spread. So in this case, you may just want to have a little table on your note card reminding you of how to find the and or for independent and disjoint. For independent, the and is just multiplying them together. For disjoint, the and is 0. And then the or is always going to be the two things added together minus whatever the heck we had here. So the same thing, except for this time we won't have to subtract off anything. So again, note card stuff. You have a note card to write down all this stuff. And like I said, especially if you do all the sample exams that I put up, you'll find that my patterns, the same questions appear on every exam. I literally have like a checklist of questions I have to put on it. So as hard as the material is, as difficult as probability is, you know exactly what's coming. So it's very easy to practice and become good at those things versus exam 1 where I could kind of get more outside the box. There's 2 more questions. We're moving like down in terms of points and probability of being on the exam, right? So the next 2 questions that are on I always put on the exam. I like to put something on the exam where the formulas save the day. So I've given you 2 big display ones where I tell you what display is going to help you. But I like to have one where it's really all about, can you translate what was given? And then can you figure out how to use the formulas or a display to get me the answer I want? So just know that there's going to be one more, and for students, this is the more challenging one, but if you take the time to break down the probability notation and then use your formula sheet or think about the different displays, you'll be able to get that question. And then the last one, which students tend to actually like, is that sampling without replacement, which is the one where we have the different fractions that change, right? And so again, here, my biggest mistake students make is answering the wrong question. They just don't pay close attention. So remember, we had like 5 different things that were pretty common: all, none, exactly one, not all, at least one. So all was we needed the thing that we were looking for twice, so maybe this was a green M&M. None was that they both weren't green. Exactly one was one we had to do 2 times. And then not all was 1 minus all, and at least one was 1 minus none. So again, I broke all these down on that one on the one problem, and there's a ton of them in the practice problems. But I find students, the most common mistake, again, is just answering the wrong question or multiplying by 2 when they shouldn't, or forgetting to multiply by 2 when they should. So again, think about what you might want to have on a note card that would get you this question. But again, it's one question. It's a 4-point question. The only way it ends up being more is if I turn it into a probability display question for part 5, which you might have seen, I think, on the exam from not last time, but the semester before. I did one with avocados with that. So anyways, this is part 4 in a nutshell. I know it seemed hard. I gave you some really challenging questions on the knowledge check and on the Kahoot, but they really boil down to these 5 questions on the exam. A big tree diagram with the follow-up. A lot of people miss points on these, so go back. If you haven't done those corrections, look through them. The key is going to be up. In fact, it probably already is. I had them set to a release 2 weeks after they were due back. Contingency table, again, straightforward. The hardest part for students here is filling it out. I have a lot of students who, as soon as they forget where things go, they can't fill out the table. But again, make up values or ask Professor Steele to fill it in, so that way you can at least get the points that come after. Independent and disjoint, that part is challenging, but it's one question. And then formulas, again, another challenging one, but one question. And then I feel like sampling without replacement is one that we do pretty well at. And I'm pretty good with partial credit on that one. It's always a free response. So as long as you show your work and I can see that you've changed your values based on the without replacement, I'll give you some credit. As long as you have the correct mechanics, I'll give you some credit. So showing work, putting down your reasoning, I'll be very generous with partial credit. And you really shouldn't need it because there's more than enough opportunity to practice these things and get really good at them. But as you go through sample exams, think about these 5 categories, and as you do a problem, which category it falls into, because that'll also make life a lot easier for you when it comes to the exam. Is like, okay, I just did that question. That's done. Now I know I don't have to do that anymore.